What if I told you that you could transform old DVD motors into a fully functional CNC plotter? Sounds crazy, right? Well, in this video, I'm going to show you exactly how I built this DIY CNC plotter using tiny stepper motors, an Arduino CNC Shield, and a lot of creativity. This is not just any plotter. It's built entirely from recycled parts, and it's surprisingly accurate. Whether you're a hobbyist looking for your next project or someone curious about the magic behind DIY machines, you are in the right place. By the end of this video, you'll have all the tools and knowledge to create your own CNC plotter. So, stick around, let's make something amazing together. All parts for this plotter are collected from scrapped DVD drives. First, using 4mm old plastic sheet, we created X-axis as shown here. Here we decided to follow low-profile design, but it's up to you to change the design to your liking. This SM15DD is a tiny stepper motor which we found from old DVD drive. We also found these two 3mm shafts from the DVD drive. For Z-axis, we are using small servo and pen holder collected from rounder compass. Also check the image, how we customize the pen to work with servo movement. Insert pen in the holder and hook the wire on the servo arm. Here we are using cheap SG90 9-gram servo motor for our plotter. Similarly, for Y-axis, we extracted complete laser setup along with base, which comes in any optical drives. We also installed vibration dampers to prevent plotter to slip while pen is touched down. We also have SM15DD motor here, which can travel maximum 50mm on the axis. Take ribbon cable and solder them on the stepper motor as shown here. SM15DD is a bipolar motor, so red and orange wires are connected to one coil while yellow and green wires connected to another coil. Just remember the color order. You have to plug the cables in the shield in the same order. Now take socket head screw and nut and install the X-axis module on the Y-axis module as shown here. Just make sure not to over-tie the nut, and also make sure don't leave the setup loose as it will affect the plotting quality. Once the tightening is completed, we are ready to wire things up together. And here is the wiring diagram of the CNC plotter. Now we are ready to connect components together. Take the CNC Shield and put the jumpers on the X and Y axis to enable micro steps. These jumpers will enable 16 micro steps of the SM15DD motors for better accuracy. After Y-axis, do the same for X-axis to enable micro steps. Now take a 4988 stepper motor drivers and install them on the X and Y axis slots. Check the direction properly. Take second driver and install on the Y axis slot. Check our self-balancing robot video to learn how to set reference voltage. Here we are using UNO Wi-Fi board, but you can use Arduino UNO as well. Now we need to install Arduino CNC Shield on the UNO board. Check the direction and gently apply pressure for proper installation. Now check X and Y axis header pins. We have to connect X and Y axis motors to these pins. Check the color order of the wires soldered on the motor, as in the same order we have to install pins on the CNC Shield headers. As you can see, the color order is green, yellow, orange, and red. So in the same order, install pins on the headers one by one. You can reverse the order if your pin moving in the opposite direction. Now do the same thing for X-axis and connect motor wires to the CNC Shield. Here, follow the same process and color order. Now take the servo motor wires. We extracted signal wire from the pin, as we have to connect it separately on the CNC Shield. SG90 servo runs on the 5 volts. So connect red and brown wire to 5-volt rail of the CNC Shield, as shown here, and signal wire to Z+ pin of the Shield. Now our setup is almost ready, but software part is still left. Let's see that. Connect Arduino board to the PC and note down the COM port allocated to our board. Here we got COM port 6. For this project, we are using Benbox software, as it is compact, straightforward, and its interface is really simple. Once the software installed, change the language and go to the installation directory. You will find the drivers and software of the plotter in the ROMs directory. You will also find some image to calibrate the plotter. Now go to the settings. Here you will see COM port where our UNO is connected. Now to upload software, click on the button as shown here and select the COM port. Select UNO board and click on the Choose Firmware button. Go to the installation directory of the software and go to ROMs folder. Select latest Benbox laser or MakerBox 328P firmware as shown here. 328P is Atmega chip of the UNO board. Here we are choosing Benbox laser 328P firmware. Now hit on the flash button and wait for the firmware to be uploaded. Once you see the right mark, close the window. Now select the COM port and enter the parameters as shown here. Two and 3 are the pins of the Arduino board for X and Y axis steps. Similarly, 5 and 6 pins for direction. Leave the min and max values as it is, as we are not using in stops here, and change the ppm values to 320. As we are using servo as a z-axis, enter pin number 11 in the both servo fields, and enter 1500 in the feed rate field. Once done, save the settings to the board. Now go back to another window. Here enter pin up and pin down angle as shown here. You can change these values according to pin up and pin down movement. Enter speed, time and step values as shown here. In the carve mode, select outline. Select curve and in servo in the next two fields. Once done, again save this by hitting the button. Now download any vector PNG image and select it from the directory. If the size of the image is too big, reduce the size using mouse scroll wheel and dragging small square at the bottom right corner of the image. Red circle at the top left corner is 0 point of the image. Once the size reduced, click the scroll wheel to bring the image to 0 axis position. Our stepper motors can travel maximum 50 millimeters distance, so set the image size within this range. You can see small square on the top right corner of the image. Click on it to invert black-white color. Flip the image and set the brightness. Set the parameters to your liking and click the button to go back to the main window. Now hit the play button to start plotting the image on the paper. You will see the current plotting position live in the software and the progress bar in the bottom side of the window. We are seeing software window currently, but actual magic is happening on the paper where pen is plotting the same image on the paper. Want to see the magic? Let's see another perspective. And here it is, the moment we've all been waiting for. After all the effort, troubleshooting, and setup, our CNC plotter is finally bringing designs to life. Look at how precisely it moves, turning simple lines of code into art. It's hard to believe that these smooth, accurate movements are powered by salvaged stepper motors from an old DVD drive. This just goes to show how much you can achieve with a little creativity, patience, and some basic components. One of the best parts of building something like this is seeing your ideas come to life right in front of your eyes. And the best part? This project doesn't just save money. It's incredibly rewarding to build something from scratch and see it work flawlessly. Thank you so much for watching. Don't forget to like, share, and subscribe for more exciting DIY projects like this one. Until next time, happy making!